All right, welcome Algebra 2. We are going to look at section 5.2. So as always in these videos, make sure that you have your notes out, you're ready to go. Feel free to pause, rewind, fast forward some of the sections of the video, and let's get right to it. So in section 5.2, we're looking at evaluating and graphing polynomial functions. So the first thing I want you to put in your notes is that title, but then also we have a bunch of learning targets that we're going to get to. One of them, the first one is I can write a polynomial in standard form. So we're going to talk about what is a polynomial and the characteristics of that. Determining the degree of a polynomial. We're going to use direct and synthetic substitution to evaluate numbers in polynomials. We're going to graph a polynomial, and we're going to talk about end behavior as well. Okay, let's first look at what a polynomial, the definition of what a polynomial function is. So polynomial function follows this format here, and it'll be easier to see once we see an example of it. But some of the key things to look at are, something is a polynomial if you have this form. Basically, it's a sum of different terms. It's a sum of monomials. And these exponents right here, the exponents of those terms have to be whole numbers. They have to be positive. It could be 0, but it has to be positive numbers there. Otherwise, it's not a polynomial function. The term right here, this constant term, is called the leading coefficient, and that's important. And this number right here, this n number, is going to be called the degree of the polynomial. And that's the largest exponent that you're going to see in the terms. All right, something that you might want to put in your notes, maybe just hit pause and write some of these things down, are the common types of polynomials and what their names are. So on the left, you can see we have what is the degree of the polynomial, and then what is it called? So we have constant, we have a linear, which is all chapter 2 and chapter 3. We were talking about linear functions. So it has this form right here. MX plus B form. Maybe just write down, these two columns and maybe just an example here might be sufficient. We have a quadratic, which we actually haven't talked about yet in this class, but we will jump back to it. If we have a degree 3 polynomial, which is x cubed, it's called cubic. And then if it's to the 4th, it's called quartic. All right, so looking at our first example. I don't know why this stuff is in here. All right, so our first example is to simply decide whether the function is a polynomial function or is a polynomial. If so, write it in standard form and state its degree, type, and leading coefficient. So each one of these, I want you to write these down, and then we'll just basically pick out what type of polynomial it is, if it is a polynomial, and then we'll keep going through. So the first one, f of x equals 6x to the 1/2 minus 5x. So this right here is not a polynomial function, or not a polynomial. And that is because it has a term here that has an exponent that's not a whole number. It's a fraction. So that automatically makes it not a polynomial function, and so we can go to the next one. If you look at part B, this is a polynomial function because it is basically a sum of terms, or in this case, there's subtraction there. But we have a bunch of terms here, and each of these terms has an exponent that's a whole number or positive. The exponent could be 0, or it could be positive. And so this is a yes. If we wrote this in standard form, okay, standard form just means we're going to take the terms that are written there and we're just going to rewrite it from the highest exponent down to the lowest. So I would just say negative 8x to the fifth, all right, plus x to the fourth, minus 4x squared, and then plus root 10. Root 10 is the constant term. And so if we look at the type of polynomial here, if you look at the type of polynomial here, it's the largest exponent is a 5. So in that list that we just had, it doesn't, I don't think it has a special name. We're just going to call it a degree, this is a degree 5 polynomial. And the leading coefficient, so we'll just say the leading, I'm just going to abbreviate here, leading CE, leading coefficient, is just negative 8. And basically, when we get into this and we talk about graphing and the behavior of this function, those two things are the most important. The degree and the leading coefficient will determine what this function is really doing. It's sort of the main driver of the function. All right, looking at C, we have x cubed minus 4/5 x squared minus 1. And so we look at this, and this is, yes, this is a polynomial. It's already written in standard form. You can see that the exponents here are going down. We have the x cubed term, then we have the quadratic term, and then we have the constant term going from highest exponent down to lowest. The type here, this is a degree 3 polynomial, also known as cubic. And the leading coefficient, so the leading coefficient here is just 1. If we look at D, if you look through these exponents, looking through the different terms that we have 4 terms. This term right there, that has a negative exponent. And so since that's not a whole numbers are any number from 0 and then all the way up. That doesn't have a fractional component, so 0, 1, 2, 3, 4, 5, etc. Negative 2, since that's negative, it's not a polynomial, so not a polynomial or polynomial function.